Bismillahirrahmanirrahim. Good afternoon, everyone. Today, I will try to illustrate the Ohm's law experiment. Okay, the main purpose to this lecture to make the student can verify the Ohm's law at first, and the second purpose, the second goal is to make the student can determine the resistance value from circuit like that. Okay, the idea it's easy because I will give you the results. I'm talking about the column. There's the current and voltage results, and after that you must plot the diagram and use the main function. I'm talking about the slope equal the resistance reverse. The most important thing in this lecture is how you can plot the diagram, how you can determine the slope correctly. That's it. Here at this question, in your exam, maybe you will take question like that, but the results, I mean the voltage and current results will be different. Let's read this question and try to answer it. Question here, according to the circuit and the column below, find the resistance value. Okay, I have this circuit like the circuit in your sheet. Here, we must calculate the resistance value when the results about the current and voltage in your paper, in your question paper, okay, in your exam paper, let me say. Here, diagram of the circuit, all of these. Here, at first, let me say, approximately, I will give you in the exam paper, the units will be one of them, maybe volt or ampere, and the another will be at milli, okay? Because that you must convert one of them to make all of these units standardized, okay? These notes, I think it's important, or let's say it's something like review to us. Milli equal 10 to minus 3 here, micro minus 6, nano minus 9. By that, because it was milliampere, that means 10 to minus 3 ampere. That means all of these units from the, let me say, from the big units, okay? All of these milli, all of these nano, all of these ampere or volt without nano or micro. The main point here, the main note here, all of these units must be standardized, okay, to avoid any mistake. And after that, like we know, current will be at y-axis, volt will be at x-axis. And start to plot all of these. I have dot 1, dot 2, dot 3, dot 4, dot 6 volts at the x-axis. And here I have 0.2, 0.4, 0.8, 1.2, 1.5 milliampere, okay? Or let me say multiple 10 to force minus 3 ampere. That will be better, okay? Here, the relation between them is linear. By increasing the first one, the second will increase too. Here, I selected any 2 points, the last one, and at 0.8. I think the plot is very clear. And after that, here I have 2 points in the voltage axis, 0.6 and 0.3. That means that's my triangle at 90 degree. Here, the important line here, my slope is done and ready. Let's amplify the slope equation, delta I divided on delta V, by that 1 minus 5, 1.5 minus 0.8 divided on 0.6 divide minus 0.3 to be the result equal to 0.333. Resistance equal reverse of slope, that's mean 1 divided on 2.333. The resistance is equal 428. It's acceptable. Why? Because my resistance was equal 0.5 ohm. That means the result is acceptable. Let me say and mention two very important notes. From the slope properties, the slope must equal at each 2 points. 2 points. But here the situation is different because I started to do that with these 2 points and with the other 2 points. The result didn't equal each other. Why? Because this diagram, this results from my imagination. These are not real. These are not really from ammeter and voltmeter. Because that, I focused on these 2 points just to illustrate the main idea, just to illustrate to you how you can plot and determine the slope, plot the slope, how you can write and determine these results. By that, my goal is done. Now you can amplify the Ohm's law. You can determine the result, the resistance value. That's it. Thank you about your listening or watching. Have a good day and see you at next video. Let me close it.